Hi, geometry. Section 8.4, angles of elevation and depression. So this is really the application of trigonometry that we're going to teach you this year in terms of sine, cosine, and tangent. So in this slide, you see that you have a person on the ground looking up at a hang glider, okay? So this angle formed by, and I'll try to use some bright colors like red, formed by this horizontal line and this line of sight. I'm going to label that the line of sight from the person to the hang glider. That's the line of sight. This is called the angle of elevation right here. Angle of elevation. And you can think of elevation, elevator looking up, okay? Now, there's also an angle of depression. There is an angle of depression formed by the person in the hang glider, a horizontal drawn from this person and the line of sight from the hang glider down to the person on the ground. This angle right here is called the angle of depression. Now, let me show you, or let's talk about one more thing. So notice in this right here, look, this little box right here, notice that the angle of elevation is congruent to the angle of depression because they are alternate interior angles. These two horizontal lines will be parallel. Your line of sight will be your transversal. Do you see the Z, right? See the Z. When you see the Z, those two angles are congruent, all right? Now, let me warn you. This is a warning. Many people would like to do this with the angles of depression. They like to draw a vertical from the object up and then the line of sight. And people like to call that angle the angle of depression. That angle is not the angle of depression. Be aware of that. This angle right here is not the angle of depression. So please don't make that mistake. Your angles of elevation and depression are made by horizontal lines. Horizontal lines, horizontal lines. All right, good. So I got 3 examples to show you involving word problems. All right, so the first example says, suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above ground. Approximately how tall is the turbine from the ground to its hub, round to the nearest tenth of a foot? All right, so if you look here, okay, so here's you. There's the 53 feet. Now, it does not mention your eye level in the picture. So your eye level, so from you to the ground, that's about 5.5 feet. That's going to come into play right here because that distance is 5.5 feet. This triangle is elevated. So in the end, before you put your final answer right there, you're going to have to take something and add 5.5 to it. So keep that in mind. When they talk about your eye level, there's usually an addition that happens at the end or a subtraction that happens at the beginning. All right. So be aware of that. It tells us the angle of elevation is 56.5. Horizontal line of sight. There's your angle of elevation. And again, you want to know how tall the wind turbine is, but you want to know this height from the top of the turbine, the hub, if you will, that's the hub, all the way down to the ground. So we can find X, which is right there, in this right triangle using trigonometry, but then you have to add 5.5 in the end. So this is what we're going to do. We're going to find X and then add 5.5 at the end. So how do we use trig? Well, here's our angle. What are our 3 sides? So from this angle, X is the opposite. This is the right angle. They do not give us the hypotenuse, but they do give us the adjacent, 53. Which of your trig ratios involves opposite and adjacent? That's going to be TOA. This is a tangent problem. Tangent of 56.5 degrees equals opposite X over adjacent 53. To get the 53 out of the denominator, we're going to multiply it on both sides. So 53 tangent of 56.5 is going to be our X. I'm going to multiply this out in Desmos graphing calculator, and then we're going to add 5.5 in the end. Now be very careful, right? Remember, whenever you open up this calculator, you always have to go to the wrench, and you always have to change it to degrees. I wish it would stay there, but it doesn't. So we're going to do 53 tangent of 56.5. There is the height, 5.5 feet above the ground to the hub, 80.07. It says round to the nearest tenth. So I'm going to just leave it like this for a little bit. So I can actually copy and paste that. And I'm going to add 5.5. So I just use control. So I highlighted it. I used Control C and Control V on my keyboard. And there is the true answer. When we round it to the nearest tenth, 85.57. The 7 makes the 5 become a 6. That is 85.6, and it is feet. So remember, when you answer this, 85.6 feet, remember that second box. Let me erase those two. So 85.6. That second box is for your units. And remember, with feet, there is feet or there's FT, whichever you choose will work. Okay, next problem. All right, it says to approach runway 17 at the Ponca City Municipal Airport in Oklahoma, the pilot must begin at a 3-degree descent, starting from a height of 2,714 feet above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airplane at the start of its approach? Round answers to the nearest tenth of a mile. Okay, so first of all, this angle of descent is another way of saying angle of depression, right? Angle of descent and depression are the same thing. So notice in this picture, they have a horizontal drawn from the airplane. They have the line of sight. There is your angle of depression. Very good. Now, I did not mention this, but typically I don't use the angle of depression. I typically use the angle of elevation, and I'll show you why in a second. Now, it says that you are 2,714 feet above sea level. So this height right here is 2,714. However, it's not, because that's the height above sea level. It actually goes down here, and this is tricky, to where sea level is. Because it says here, this extra information, the airport is 1,007 feet above sea level. So the airport itself, this height is 1,007. It's like the eye level question, right? So this 1,007 is also over here. So the 2,740, this number, 2,714, goes all the way from the airplane down to sea level. This 1,007 goes from sea level up to the airplane. Your triangle is elevated. So we're going to have to do a subtraction at the beginning to figure out what this measurement in the right triangle is. That's confusing. I get it. I'm sorry. And it says to the nearest mile. So now be very, very careful. Everything here is in feet. That's miles, right? Do we know that 1 mile is 5,280 feet? Do we know that? Hope so. So how far from the runway is the airplane at the start of its approach? So this is where it's starting its approach. This is the airport. This is what I'm trying to find X there. Okay. Now, here is why I typically use the angles of elevation. This 3 degrees is outside of the triangle, but this angle of elevation right there is inside the triangle, and I'll put 3 degrees right there. And I'm actually going to make this picture a bit bigger. So here's my 3 degrees. Here's my X distance. And now what is that distance? We need that. Well, we're simply going to subtract 2,714 minus 1,007. And I'm going to do that in my handheld calculator. 2,714 minus 1,007. And that's 1,707. So that is that height right there, 1,707. And we will use trig to solve this. 3 degrees is my angle. I know the opposite side is 1,707. I also know the hypotenuse, or I don't know the hypotenuse, but that's what I want to find. So there's the two sides I want, opposite and hypotenuse. Which trig is that? That's the SO, which is sine. Sine of 3 degrees is going to be equal to your opposite side, 1,707, divided by your hypotenuse x. And now remember, when your variable is in the denominator, we just do our little switcheroo. And to solve for x, we're going to do 1,707 divided by the sine of 3 degrees. So we're going to type that in our calculator. We will not be done, though, because of this miles issue. And we'll take care of that in Desmos graphing calculator. Okay, so again, make sure I'm in degree mode. I am. Here we go. So I'm doing 1707 divided by the sine of 3 degrees. Remember, do not ignore the division. And that is the distance in feet, right? So this is in feet. But to find how many miles that is, we have to take this big number and divide by 5,280. Again, think about it, right? Typically, when you talk about miles, it's a lot smaller number than it is feet because, again, there's 5,280 feet in a mile, right? So we're going to take this and take this and divide it. Oh, I don't like that bracket. Sorry about that. Take this number and divide it by 5,280. And there is our number of miles. We're going to round to the nearest tenth. So 6.17. The 7 makes the 1 become a 2. 6.2 miles. So again, when you go back to Edge Elastic, make sure you pick the correct one. So 6.2. And then again, miles is mi, not miles squared. We're not doing area or anything. We're just doing length miles. Cool. All right, last problem coming up here. Sorry for the long video. Number 3 says the world's tallest unsupported flagpole is 282 feet tall, steel pole in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long. To the nearest degree, what is the angle of elevation of the sun when casting the flagpole's shortest shadow? So there's no picture bummer, so we got to draw it ourselves. So let's start with that flagpole. So there's my flagpole. It's 282 feet tall. Now, it does cast a shadow. So I'm going to say my sun is over here. So we'll cast a shadow of 137 feet. And we want to know what is the angle of elevation. So this is my horizontal. My line of sight to the sun will create that angle of elevation right here, which is going to be our x. We are assuming that the flagpole is perpendicular to the ground, and here's our picture. I suppose I should have made my triangle bigger, but so it goes. So if x is my angle, 282 is the opposite. They do not give me the hypotenuse, but they do give me the adjacent. It's 137. And which involves opposite and adjacent? That is TOA for tangent. Now, again, we're finding an angle measure. So we're using inverse tangent. So x equals the inverse tangent of, and it is still opposite over adjacent. And now we're going to plug this in, and we'll get our angle just right away, round to the nearest degree, so no decimals. Okay, so we're going to go back here. Again, make sure we're in degree mode, which we are, degrees. So I'm going to type in tangent. And again, I'll use the caret button above the 6 to put my -1. Again, that's just notation. And again, it's 282 divided by 137. And there is my angle, 64.0. The O keeps the 4 the same. That'd be 64 degrees. So we go back to Edge Elastic and we type in 64. The degrees is right there, so no need to put the symbol in. Cool. All right, good. So again, if there is no picture drawing, get out a piece of paper, draw that picture, create your trig equation or your inverse trig equation, and use the calculator. All right, hopefully this goes well. If not, ask questions.